Hi, welcome back to our video. In area problems, there are cases that we may be encountered when we are finding areas. Okay, so we have four cases. You have four cases. We have case one, wherein let me illustrate it. Say this is our x and y axis, and we have the curve and the lines. Okay. So we have here the case one, and we may encounter this um, when getting our area bounded by this region of, say, this red line here is our curve with equation y is equal to some function of x. Then below the x-axis with two vertical lines, x is equal to a and x is equal to b. Okay, so if we have this case, then we will use our vertical element, this one, from this one. Say this is our strip, this is our y strip, which is equal to some function of x, and this point here is our d of x. And by having this kind of case, we can now compute our area by having dA is equal to this y, this length, multiply by the width dx. And having the totality of this, we have from point A to point B, we have the y, which is equal to our f of x, then the x. So we can compute this case using the formula this. So for case 2, say this is our x and y axis, x-axis, but our curve, instead of in this side, our curve is located here, having y is equal to some function of x, and point x is equal to a, x is equal to b. Yan. Sorry. If we have case like this, our strip can be represented by y, negative y, since it's located, negative y, which is equal to the negative f of x. And then this part here is our dx, and having this one, our dA is equal to this negative y multiplied by the dx. And if we integrate this to have the totality of the area, we have the integral of negative y dx, wherein our negative y is equal to negative f of x dx from point A to point B. Okay, so again, if our area is located at the upper part of the x upper part positive part of our y-axis, then our length y here is positive y, or equal to positive of x times multiplied by this part dx. And then if our curves is located at the negative part of our y-axis, so we have negative y here multiplied by the dx, wherein our y is equal to some function of x, so we have negative f of x dx. Okay. Yan. Then we have also the case 3 and case 4, wherein our case 3 case 3 case 3 is when we have the region, this one, when we have a region bounded at the right by the curve x. So this part here, say we have, this is our y, this is our x-axis. If we have a region bounded by the right curve, say this is our curve, this is our curve with x is equal to some function of y. This is the formula of our curve. Then we have the limits, or the line from y is equal to a, or let us change the letter, from c to y is equal to d. Okay, this is point. Okay, then of course our element here is from this curve, sorry, strip is given by the length, which is equal to x, width, which is equal to some function of y. Then this is our dy from point 1 to point 2. Okay, then from here we can now compute our area is equal to the length times width. We have x times this one dy, wherein our x is equal to some function of y, gy, and then our dy. Then we can now find the totality by integrating it from point C to point D. Okay, so this is now our equation for case 3. And for case 4, lastly, for case 4, say we have this x and y axis, and then we have a region on the left side of y-axis. Say we have this curve which has the equation of x is equal to g of y, some function of y, and then our line is from y is equal to c and y is equal to d. And then our strip here is from this curve up to the y-axis, so we have this length here equal to x, which is equal to some function of y, and this is our dy. From here, our dA, I mean this is our negative x located at the this is length negative x located at the negative portion of our x-axis, or in the left side of our y-axis. So we have here dA is equal to negative x dy. This is our negative x. Negative x. This length is our negative x. And this length here is our dy. So we have negative x dy, or our negative x is equal to negative gy dy. And by integrating this, or having the totality or the summation of this area from point C to point D. So this is now our formula for case 4. Okay. So once again, in finding the areas bounded by the curve, given by the curve, either y is some function of x or some x is equal to some function of y, and then bounded by the line x is equal to a to b, or line bounded by y is equal to point C to point D. Then having the strips, we have 4 cases wherein this is our equation of the area. For case 1, we have positive f of x, this part here, which is equal to the y, which is this is our length. Our dx here is our width. We have area in the totality from A to B. So we have positive. And then for y, since our length is located at the negative side of our y-axis, then we have negative y. Then negative y is equal to f of x. So we have f of x dx from A to B. And for C and D, our curve is located at the right side of the y-axis, or located at the positive side of our x. That's why we have this length, positive x. So we have positive gy here. And for here, the other side, we have case 4. Our x here is on the left side, or left side of the y, wherein we have a negative x here. That's why we have negative x is equal to negative gy, and then our dy, and then the limit from C to D. Okay, so in the next video, we will have an example of these cases randomly. So see you on your next video.